Hello, this is Dr. Costa again from costamedic.com, and in this video I would show you how to do an independent samples t-test. An independent samples t-test is done to compare the means between two groups. Here we have gender column, and in gender column we have males and females. The males are represented by number 1 and females are represented by number 2 in our dataset. This is the BMI column. In earlier video I have shown how to calculate BMI from height and weight data. BMI is a numeric data. By independent sample t-test we can compare the mean BMI of all males versus mean BMI of all females. Before running independent sample t-test, I would like to see what is the mean BMI of all cases, what is the mean BMI of males, and what is the mean BMI of females. Analyze descriptive frequencies from statistics, means and standard deviation. Continue. OK. So this is the mean BMI of all cases, 23.475 plus minus 3.2586 kg per meter square. If I want to find the mean BMI of males and females, then I have to split the data into two parts. Groups based on gender. OK. Now analyze descriptive frequencies. All the things were previously set. OK. So this is the mean BMI of males, 23.877 plus minus 1.93, and this is the mean BMI of females, 23.07 plus minus 4.23. Now from this data we can see that the mean BMI of males is slightly higher than mean BMI of females, but we would do the independent samples t-test to answer the question, is these mean difference statistically significant or not. Another very important thing I would like to show you before starting independent samples t-test, and that is the assumptions of an independent samples t-test. You can only do an independent samples t-test if your data meet all these requirements. First thing is independence of the observation. Each subject should belong to only one group. There is no relationship between the observations in each group. It means that the males and females should be separate groups. No male can go inside the female group, or no female can go into the male group. These two groups should be entirely separate and should not mix up by any means. The next assumption is no significant outliers in two groups. So there should not be any outliers. For example, if one person have dwarfism or achondroplasia and his weight is severely low, so his BMI will also be affected. This type of special extreme cases should be omitted from the dataset before running an independent samples t-test. Another thing is normality, which means the data should have normal distribution. In our case, BMI should be normally distributed. And another is homogeneity of variances. If homogeneity of variances is present or equal variance is present, then we can take the t-test result. Otherwise we can also do a t-test, but that will be Welch t-test. Running the t-test is a very easy task, but make sure you do not forget about the assumptions of t-test. If your data is not normally distributed, then you can do Mann-Whitney U-test instead of independent samples t-test. The Mann-Whitney U-test is a non-parametric alternative of independent samples t-test. Now we will do the actual independent samples t-test. We will go to analyze, then compare means, then independent samples t-test. Here we will put gender in grouping variable box. We will define the groups. I showed you earlier that the males were 1 and females were 2. So I have written these numbers in group 1 and group 2. So I have defined 2 groups. Now I will click continue. Then I will put our test variable. Our test variable is BMI. Basically I have to do nothing else. I have to just click OK. You can see that we did not get the t-test results. Instead we got one warning message. This is because I forgot to unsplit the variables. In the data split file, the dataset is still splitted by gender variables. So I have to select this option, analyze all cases, do not create groups. Then OK. Then I have to rerun the t-test. Analyze, compare means independent samples t-test. Everything were previously selected. So I would just click OK. This is the independent samples t-test result. The first table is showing group statistics. Here it is showing that we have total 15 male cases and total 15 female cases. The mean BMI of males and females, which I have shown you earlier by split variable function, and it is also showing the same mean values. The mean BMI of males is slightly higher than mean BMI of females. This is the independent samples t-test table, and in this table we have Levin's test for equality of variances, and here we have a significant value of 0.000, which means equal variances not assumed. If it was more than 0.050, then we would have considered equal variances assumed. In our case, we have to consider equal variances not assumed. These are the significant values or p-values of t-test results. Since this is less than 0.050, we would take equal variances not assumed value as t-test p-value. So we would write that mean BMI difference between males and females were not statistically significant, since the p-value is 512, which is way bigger than 0.050, and this is obviously our 95% confidence interval data, lower limit and upper limit. This column is showing the actual mean difference, which is 23.8773 minus 23.0742. So we did not get any statistically significant difference between the males and females in terms of their BMI. Please click on the subscribe button if you like this video. Please visit our website. We do medical illustration, animation, data analysis, and medical article writing. Thank you.